Alright, so just quickly running through some things to help clear up the domain and range of some composite functions. So remember that we got to think about composite functions not only in their simplified end state, but how do they work when I put something in. So remember, a function's a machine. A function, when you put some kind of x input in, it's going to give you some other output, and that output becomes the new input for the next function. So if some input we put in doesn't work in the function, for some reason it doesn't happen, well, we actually don't get an output, so you can't actually move it on to the next phase of the function, which means eventually we don't get anything if our first function just doesn't work. So if we look at question 15, let's look at that in detail. So f of x was the square root of 3 minus x, and g of x was x squared minus 2, and y is g of f of x. So natural instinct would be to substitute everything in, and we get then that y is just the square root of 3 minus x, all squared minus 2. Now logic says when we simplify that, we get 1 minus x, and 1 minus x, it's just a graph of a straight line going downhill through positive 1. But if we take a moment to come back and think about how this function works, we really need to think about our first input, because the way our function works is f of x needs to work. It needs to happen. We need to get an input into f of x to actually even start to use g of x. So when we look at f of x, well, its domain is x needs to be less than or equal to, not that one, sorry, needs to be less than or equal to 3. If x is greater than 3, we're starting to find the square root of a negative number. And when we find the square root of a negative number, it doesn't exist, so that function stops working. So we can put, all our x values that we're putting in have to be less than or equal to 3. So they're the x values we can put in for f of x to work, which means g of x, it's restricted when it comes that way to, x needs to be less than or equal to 3. So when it comes now to graphing it, its graph is going to stop at 3, because any values greater than 3 will cause f of x not to work. And if f of x doesn't work, you can't then proceed on to g of x. So that's why in this function here, for y, the domain of y is, also x needs to be less than or equal to 3. All right, I hope that helped clarify that one. And then let's go through and look at question 21, part 2, and we're going to look at it in the same sort of context. All right, so we know with logs, we can't find the log of a negative number, so f of x, it makes sense that its domain, x, needs to be greater than 0. And then g of x, well, it's just a parabola. So if I was to think about this, it's just a parabola, positive parabola, that passes through 1 for all of x. So one thing that I'm starting to think about g of x here is that its range is going to be y is going to be greater than or equal to positive 1. So that's the range of its outputs. And I can put any x in there. So when I start to thinking about it as the function, as the composite function h of x, so h of x, well, I can put all x into g of x, and when any x goes through g of x, its output becomes positive values. The output of g of x is always going to be a positive value, and because then it's always going to be a positive value, f of x is going to work. And then because f of x is going to work, we now know then, because of that, our domain is, all x, because of the fact that g of x is a parabola. It's concave up through and shifted up 1 unit. So because its range, is greater than or equal to 1, all of its values become positive values, and because all of its outputs are positive values, that means then our input for the f of x means x is going to be larger than 0. So that's why this domain is now all of x. All right. So when we do this, there's multiple layers here that we have to think of, and so when we're asked to find the range or domain of a function, we need to think about what's going on at each step of the composite function and how that may or may not impact the next phase. I hope that helps.